All right, so this next topic is graphs and equations. So what we're going to actually have a look at is different regions of the number plane. So see the yellow section there? That's what we say, anything that is positive, it's above the x-axis. Anything that's below the x-axis we say is negative. If it's on the x-axis, it's neither positive nor negative. Okay, so that's what we're talking about when we talk about the sign of a function. So when the sign is positive, it's above. When it's negative, it is below. Okay, so basically it's where all the y values are. Okay, so when the y values are positive, it's above. When the y values are negative, it's below. Okay, so let's have a look at some examples here. So if you look at the first graph here, this is the graph of y equals 2 to the x. Okay, so you can see that this graph is always a positive function. It's always got above the x-axis. It never actually touches. So that's why we say that the graph goes, when we describe the x values, they're always between minus infinity and infinity. Okay, you might recall back in term 1 or 2, I think it was, one way of writing that was with open brackets, and we had minus infinity comma positive infinity, because you don't include infinity, doesn't exist. That's why it's a bracket, not a square bracket. Okay, so this is an example of a function that is negative because it's always below. Okay, it's always below the x-axis over the entire domain. So that the x value still goes between minus infinity and to positive infinity. Okay, you might recall, how do we get this graph? See what we've done here? So x minus 2 in brackets squared. So that value here, you go across positive 2 and then down to minus 1. Okay, and that's where it comes from. And then the minus just means it's upside down. So it's just, we're going to get to go over graphs again, which is really handy to learn how to draw these. So this is the graph of y equals x cubed. So when is the graph positive? The graph is positive here. In other words, whenever x is greater than 0, not equal to 0. So how do we write that? Curvy bracket, put 0 first and then put positive infinity. Okay, the graph is negative when it's here. Okay, when it's underneath the x-axis. How do we write that? So the negative infinity goes first because it's on the left all the way to 0. Okay. So let's have a look at this first interval notation. So do you remember what the square brackets were for? Yeah, it's closed. So it means that it actually, it means that it includes that number, okay? Whereas the brackets, the curvy brackets are for open circles. Like and sometimes, so something like this, see how that's equal to? That's why it's a square bracket there, okay? Whereas because there's no equal here, that's why that's a curvy one. All right. So composite functions. So if you've got two functions, fx and gx, so we're going to go through all of this again, which is really good. Two functions. The composite function, okay, so the composite is where you insert one of the functions into the other. Okay, of the two functions can also be written, just be aware, remember the terminology for that. That's called a composite function there. All right, so let's have a look at the first example. Okay, so, all right, so let's have a look at what we've got here. So we've got fx is x plus 3 and gx is equal to x squared. So what we're doing here is when we put this into gx, because fx is the one that we're putting into gx because it's inside, then that x becomes x plus 3. So that's why it's x plus 3 squared. Okay? This one here, so if you have a look here, what we've got, okay, if we go and put, let's go and work out what gx is first of all. So what we're doing is we're inserting x squared into fx. So wherever the x is, this becomes x squared plus 3. So when we then go and put the 2 in, we get 2 squared plus 3, which equals 7. Is that all good? Yep. Okay, cool. All right, so let's flip over the page now. All right, so let's have a look at the examples here. So we've got, these are graphed intervals. So first of all, we're going to write as an inequality. So this would be all the numbers. These are both less than. So the fact that this is a closed circle means that that one is an equal sign. That's an open circle, so we'll leave it. So these are all the numbers between -6 and 8. Okay. So that means that the two numbers in interval notation are going to be -6 and 8, but we've got to determine which one's the closed and which one's the curve. So which left or right is closed? Left. So that's a square bracket and this one is open. Okay. So how would I write the inequality for example 2? Yeah, less than or equal, less than or equal to, and then I would have 8. Yep. So with they're both equals. 8 or 6? Oh, sorry. Sorry. Can't even read. 6. Okay. So the two numbers in here for interval notation. What kind of brackets do I have?
Both square.
Both square. Excellent. All right, so what would be the third one?
Would that be negative infinity?
Oh, let's do the inequality first.
Oh, yeah.
It's all the numbers that are less than or equal to 2. So this would be negative infinity like you just said. So my two things are going to be negative infinity and 2. Now, which one is square?
The right hand side.
Yep. And the other one is a bracket like so. Okay. All right. So what happens when I've got them separate? So these are all the numbers that are less than, and these are all the numbers that are greater than. Now, that's a closed circle, so I've got 2 here. So x is less than or equal to -4, or x is greater than 2. So what we've got there are 2 regions. So we've got the union of all the numbers between -infinity and 4, and that's a square bracket. And then I've got all the numbers between 2 and infinity. Does that make sense? Yeah, cool. All right, so let's have a look now at example 2. Okay, so let's do, now I haven't got a lot of room to work here, so I'm going to have to work across the page, but normally you would work down the page. So we're actually inserting gx into f. So we're putting 3x where the x is here. Okay, so this, let's work that out first. So f of gx, okay, where I see x here, I'm going to put 3x. So this becomes 2 lots of 3x minus 1. Which is 6x minus 1. So what you can do now, once you do that, you can actually just substitute -3 where we are. So we get 6 lots of -3, take away 1, which is minus 18 minus 1, which is minus 19. Okay, so now what we're going to do in part B, we're going to substitute hx into this one down here. So let's do that first. So I've got FH7. So I'm going to, well, let's just do x first of all. So let's go and put x squared plus 1 in where the x is. So this becomes 2 lots of x squared plus 1 minus 1. Just expand that out. 2x squared plus 2 minus 1, which is 2x squared plus 1. Okay, so now what we can do is we can put 7 in. So we put 7 in up here, so it becomes 2 lots of 7 squared, okay, plus 1, which is 2 lots of 49, which is 98, plus 1, which is 99. Is that okay? So first of all, work out what the actual function is before you substitute it in. Okay, so we've got C now. So let's have a look at C. So this one, we're going to put hx into G. So let's go and do that. So let's find G, hx. So I'm going to put that x squared plus 1 where the x is here. So this becomes 3 lots of x squared plus 1, which is 3x squared plus 3. Okay, so now I can actually... I don't need to find anything. So that's my final answer for that one. Okay, which is 3 lots of x squared plus 1. Okay. Rightio. So, we're about to sketch the curve. What type of curve is y equals 3x plus 1? Plus 2. Straight line. So when you draw a straight line, what do you normally do? Training wheels was a table of values. And then the intermediate way was to find where it cuts the x-axis, find out where it cuts the y-axis. So let's do that. Cuts, x-axis when y equals 0. So I put that in, 0 equals 3x plus 2. So minus 2 equals 3x. So minus 2/3 equals x. Okay, and then find out where it cuts y-axis when x equals 0. So you end up with y equals 3 lots of 0 plus 2, which is just 2. So here's my 2 spots. It's just a sketch. Still means use a ruler. Okay, we know it cuts at minus 2/3. And we know it cuts at 2. Label your axes. And then draw a line that goes through. Okay, and then write the equation of the line along that. Okay, so there's our first verb. So sketch. There would be 1 mark for that. What's our next verb? State. Okay, we've got to state when the curve is positive. So when is the curve positive? Yeah, along here. So what x values does that belong to? What are all these x values? Yeah. When x is greater than minus 2/3. Okay? All right. So straight lines are nice and easy. Okay, so what we're going to get down to And the good thing is we're going to be looking at different types of curves again and refreshing on how we graph. Okay. So let's have a look at example 4 here. All right. So what type of graph is this? Parabola. Okay. Can we find out where it cuts the x-axis? Yes. So cuts, let's just write that. Cuts x-axis when y equals 0. So in other words, 0 equals x plus 1, x minus 2. So that's a product of two things. For that to equal 0, either the first bracket equals 0 or the second bracket equals 0. Okay, so x equals -1 or x equals +2. So see how it's always the reverse of those two. Okay, so it cuts y-axis. Okay, when x equals 0. So in other words, y equals 0 plus 1, 0 minus 2. So that's really 1 times -2, which is -2. So that's really helpful because when I go to draw, because this is a sketch and the other verb here is state, that tells you where the marks are. So we label our axes. Now you said it was a parabola. How did you know that that was a parabola?
Well, if you expand your brackets, it's x squared.
Yeah. So if you expand your brackets, it's x squared minus 2x plus x minus 2, and you could simplify it. So you know. And is it a smiley or is it a sad? Smiley face. Because it's positive in front of the x squared. But we've got enough information here. It's going to go through -2. It's also going to go through -1. And it's also going to go through 2. So the very tipping point is halfway between -1 and 2. So it's got a distance of 3. So if I take 1.5 back, we know that at a half, okay, that's going to be the very tipping point. So I'll probably do it here. Put that -2 there. So my parabola is going to go through like that. Okay, so this is the graph of y equals x plus 1 times x minus 2. All right, so when is the curve negative? Under here. Because that's what they... Oh, sorry, it says state when the curve is positive and when it's negative. So you've actually got to do 2 here. So even if you were to do negative symbols all along here, and then this is positive all along here. So let's do the positive one first. Okay, curve is positive when... So look at all my plus signs. If I was to bring a vertical line down, it would be all the numbers here. Okay, so curve is positive when x is less than -1 and when x is greater than 2. Is that okay?
Mm-hmm.
Cool. And curve is negative when, what do you reckon it might be negative? X is in the middle. These are both less than signs. What are the numbers?
When x is greater than -1.
Yeah. So how do I write that? When it's a between, so this is the between, okay, x lies between -1 and 2. That's how you write it. Okay? All right, we've got 2 more, I think, to go. All right, so the next one, what have we... Okay, so let's have a look now at example number 5. So we've got to learn how to do parabolas again. So we've got to sketch and state. Now the symbol for positive, abbreviation is a plus with a VE. Okay, so, but when you're in the HSC, I'd use the words. But if you want to just, while you're doing this, just do a plus with a VE. All right, so we need to sketch. Okay, so what type of graph is this? Okay, it's a parabola as well. So let's find out the 2 points where it cuts the x-axis. So cuts x-axis when y equals 0. So you get 0 equals 2x squared minus 5x minus 3. How do I do that? Factorise it. So let's see if we go 2x all over 2. What do the two numbers need to multiply to give? And add to give? -5. Any idea what you think they might be? One's got to be a plus, one's got to be a minus. Not 2 and 3, it's, yeah, so 6 and 1. So it'd be +1 minus 6. And then the 2 would go into this one, x minus 3. So I'm left with 0 equals 2x plus 1, x minus 3. So you should be able to get to a point now by looking at that, x equals -1/2 or x equals +3. Is that okay? Jumping to that rather than having to set it all out. So the other thing is cuts y-axis when x equals 0. And that's pretty easy because when I put 0 in up here, I just get -3. So when I go to sketch this graph, I know it's going to go through -1/2. I know it's going to go through 3. I know it's going through -3. So when I draw this, it's a smiley face. I don't really need too much other information because now I've got to state when the curve is positive. So it's positive here. So when I bring a vertical line down, it's all the numbers that are less than -1/2. Okay, and it's positive over here. So it's all the numbers, okay, that are greater than 3. So the only new content that you're doing is learning how to state when a curve is positive or negative, because all the graphing is what you learnt in prelim, so you get to go over it all over again. Okay. Last one. So we've got sketch the curve -x cubed plus 4x and state when the curve is positive. Okay. So, what type of curve is this one? It is, and it's got a few kinks in it. So and because it's a -x cubed, what that means is that it's going to come out here and go down there. Like it's like the negative cube, but it'll have a few kinks in it. To work out where those kinks are, okay, what we can do is we can factorise it. -x, so I've got x squared. Now, because that's a negative and this is a positive, I'm going to have to put a negative there. Okay, and that's going to be 4. So this becomes -x, x minus 2, x plus 2, because of the difference of two squares. Okay, because that tells us then it's going to cut the x-axis at x equals 0, x equals 2, x equals -2. Okay, where does it cut the y-axis? If I put x equals 0 in, I just get 0. So that's really handy okay, because it's going to go through here, over at -2, and over at 2. Now, because of that negative x cubed, so remember, minus x cubed is just that one. So it's going to come down here, go back here, and then come out like that. That's all you need. Don't need to have a fancy graph. Just do your y-axis, x-axis, and label it. Y equals minus x cubed plus 4x. So when is the curve positive? Let's draw the curve where it's positive, when it's above the x-axis. So we've actually got two regions there. So this would be whenever x is less than -2 and when x is between 0 and 2. So we put 0, 2, x in the middle, and these are both less than. If your exercise asks for you to write that as an interval notation, this would be -∞, -2, and this would be 0, 2. And that's the union of both of those. And that is exercise 2A.